So let's look at photochemical decomposition now. So what we are looking at is AgCl. So what does AgCl stands for? Ag stands for what? Correct, silver, right? So this is your silver. So right. Then Ag is silver and Cl2 is your chlorine. Now let's balance it out. This looks to be very simple. So we have AgCl, Ag and Cl2. Then we have silver and chlorine, 1 and 1, 1 and none, none and 2. Again, what did I do? I wrote all the reactants in the product in the first row and the atoms involved in the first column. And I mapped it. AgCl has 1 silver and 1 chlorine. Ag has 1, right? Ag, that is silver, has 1, 1. And Cl2, there is no silver, but chlorine, there is 2. If you understand this mapping, then it's quite simple. So first we start with chlorine. It's not balanced. So on the RHS we have 2. On the LHS we have 1. So I'll just multiply with this 2. For this chlorine in this particular cell to be 2, AgCl has to be 2. Only when the silver chloride is 2, the chlorine will be 2. And so the silver atom will also be 2. There will be 2 of it basically. And so silver on the right hand side will also be 2. And so we have 2 AgCl. Exposure to sunlight will give us 2 silver and Cl2. So this is in presence of sunlight. And this is a solid. This too is a solid. And this is a gas. So what are the indicators? So one is for sure gas, right? Gas formation. The other major one is change in solid color. So we are moving from, white solid, silver, chloride, which gradually turns to gray or even black, right? These are the color changes. Then we have gas formation. So these are the major indicators. Okay, so this is the basic understanding. Next, we're going to talk about AgCl and how it got converted to Ag plus Cl2 when exposed to sunlight. So AgCl, let's have a look at it. Ag is over here, silver is over there, chlorine is over here. So this is your atomic number. Valencies is -1 and 1. That makes sense. Electronegativity, the difference is less than 1.7. The first ionization energy, they have a difference of 500 over here. Electron affinity, both want electron, so on and so forth, right? So this is a scenario. So we can clearly see that both want electron. So this behaves like an ionic bond and some degree covalent bond as well. Okay, so that's how it behaves. So basically what happens, see, when we have a chunk of AgCl2, okay, you can imagine this to be three-dimensional stuff. So when we have a chunk of it falling on the solid, what happens? The electron gets excited. The electrons, they get excited. Okay, so basically the chlorine ion loses electron and combines to form chlorine molecule. Okay, so this kind of splits up. Obviously the breakage happens and the electron from chlorine goes to your silver and that becomes a individual particle kind of thing, while your chlorine combines with other chlorine and we have gas being produced. So basically what you have to understand over here is the light excites the electron within this bond, and that leads to all of this. That's the basic thing that you can understand. Excites means what? It pushes it to higher energy level. Okay, so you can see similar behavior of silver. Says we have one more actually, if I remember right. The other one is silver bromide. I think it's that. Actually, there are two, three examples. So anyways, let's have a look at that later. So the point is, this simple exposure to light excites the electron that leads to breakage of the bond. And then what happens? There is jumping of electrons, and the chlorine combines with other chlorine to form a stable atom, and that is a gas, and that escapes. Okay, yes. So that's how you get decomposed. Remember, light also is a form of energy, and that's why when you stand in the sunlight, you get hot, right? So it carries energy, is it not? And all of these are energy. Atoms, they exist in different energy levels.